In our increasingly digital world, the need for data storage is growing exponentially. From photos and videos to complex scientific models, the amount of information we generate is staggering. But as our digital landscape continues to expand, traditional storage methods are starting to show their limits. That's where quantum memories come in, an emerging technology that could revolutionize the way we store data. Quantum memories are based on the principles of quantum mechanics, the fundamental theory that governs the behavior of particles on the tiniest scales. Unlike classical computers, which store data in bits, quantum computers use quantum bits, or qubits, which have unique properties that make them far more powerful. In the realm of quantum storage, these properties could provide unprecedented advances in speed, capacity, and efficiency. But before we dive into why quantum memories are so exciting, let's first understand the challenges we face with current storage methods. Today's data storage relies on hard drives, solid-state drives, and cloud storage systems. These systems are effective but face limitations in terms of speed, storage density, and security. For instance, as we try to store more data on smaller devices, we encounter issues related to power consumption and the physical size of storage mediums. Even with the rise of cloud storage, we're still dealing with huge data centers that consume vast amounts of energy and space. This is where quantum memories could change the game. Quantum memories work by storing information in the quantum states of atoms, ions, or photons. The key difference here is that quantum states can exist in multiple conditions at once, a phenomenon known as superposition. This allows quantum systems to hold far more information than traditional systems. For example, while a classical bit can represent either a 0 or a 1, a qubit can represent both 0 and 1 simultaneously, exponentially increasing the amount of data that can be stored. But there's another incredible feature of quantum memories: entanglement. Entanglement is a quantum phenomenon where two particles become linked in such a way that the state of one instantly affects the state of the other, no matter how far apart they are. In the context of quantum storage, entanglement could enable ultra-secure data storage and transmission. Because quantum information is so sensitive, it can't be easily intercepted or copied without disturbing the system. This makes quantum storage an incredibly secure method for storing sensitive data. The implications of quantum storage don't end with security, though. It could also radically change the way we access and retrieve data. Traditional storage systems work by locating the data in a specific location within a storage medium, which can take time, especially when dealing with massive datasets. But with quantum memories, data retrieval could happen instantaneously, thanks to the properties of quantum entanglement. This could lead to data access speeds we've never imagined before, enabling applications like real-time, high-definition streaming and the ability to instantly process vast amounts of information. The potential of quantum memories doesn't stop there. Their ability to store data in quantum states could also lead to breakthroughs in artificial intelligence, machine learning, and big data analysis. Imagine quantum machines that can not only store vast amounts of information, but process it at speeds far beyond what's possible today. This could open up a new era for industries such as healthcare, finance, and scientific research, where the demand for faster, more efficient data analysis is growing rapidly. But as promising as quantum memories are, there's still a long road ahead. Quantum storage technologies are still in their infancy, and we're facing several technical challenges. One of the main obstacles is maintaining the stability of quantum states long enough to store and retrieve data reliably. Quantum information is highly sensitive to external disturbances, such as temperature fluctuations and electromagnetic interference. To address this, researchers are working on developing quantum systems that can preserve their quantum states for longer periods, enabling stable and scalable quantum storage. Another challenge is scaling up these systems for practical use. Right now, quantum memories work on very small scales, and we need to develop ways to expand them to store large amounts of data. Researchers are exploring several approaches, such as using specialized materials that can maintain quantum states more effectively or developing quantum storage systems that can integrate with classical systems. Despite these challenges, progress is being made. In recent years, scientists have achieved significant milestones in quantum memory research. For example, scientists have demonstrated the ability to store and retrieve quantum information in certain types of atoms and ions with impressive precision. These breakthroughs bring us one step closer to creating the first commercially viable quantum storage systems. So what does the future hold for quantum memories? As the technology matures, we could see quantum memories being used alongside traditional storage systems to create hybrid solutions that combine the best of both worlds. Quantum storage could be integrated into cloud computing networks, providing the foundation for a new era of data management that is faster, more secure, and far more efficient than anything we have today. In fact, some experts predict that in the next decade, quantum memories could become a mainstream part of our data infrastructure. This could change the way we store everything, from personal data to scientific research, and could pave the way for entirely new industries and applications. The possibility of unlimited, instant, and ultra-secure data storage is within reach, and quantum memories are leading the way. While we're not there yet, the future of storage is undoubtedly quantum, and it's a future that promises to transform the way we interact with data forever.